Hello, welcome back to today's session. Hope you people have understood my previous class where we introduced network models and we were supposed to start off with problems on the network optimization models. So, coming to the first problem is shortest path problem. See, in shortest path problem, there are four different variants actually. Right, if at all you consider a simple network which involves multiple nodes and multiple links to it, right, then the shortest path that you have to find can be classified into four different types of problems. First one being single source, single destination. So I would specify any particular node, let me say node number 2 to node number 4. What is the shortest path? So if at all I very clearly specify one source and one destination, then it is called single source, single destination problem. See, there is no very good solution uh, which is explicitly designed for one source, one destination problem. So we can find a solution for one source, one destination when we solve single source with multiple destinations, right? Uh, one M variant, that is one source, M destinations. So that algorithm is comparatively a better algorithm and it will also solve single source, single destination problem. Therefore, this problem is mapped onto 1M variant. So we don't have to find a separate algorithm and solve this type of problem. If we solve a single source all destination, that is single source multiple destination problem, then the solution for this problem can also be obtained from this only. Okay. Now the problem that we would be studying is a single source all destination, single source shortest path, where I would specify one of the node as the source and from that node to all other nodes in the network we are supposed to find out the shortest path. So this has to be solved. So to solve this particular problem we make use of an algorithm called Dijkstra's algorithm. So this we will be studying now. The next third variant is all sources single destination. So from all the sources, I specify one destination. I am supposed to find out the shortest path. It is just like an inversion of the previous variant. So like the 1M variant, you have M1 variant. So here if at all I just reverse the solution from the Dijkstra's algorithm, I will be able to find this solution for this particular problem. So this variant also maps itself to 1M, right? So these three variants, all these three variants can be solved with a single variant 1M by using Dijkstra's algorithm. And the fourth variant is called all sources, all destinations. M problem, M sources and M destinations. So this anyhow we will be studying as a second problem of network optimization problems. This is also called all pairs shortest path problem, right? This we will be solving in the later sessions. In today's session, we will be dealing with single source all destination or single source shortest path problem. So first of all, what is shortest path? A path with minimum weight is called shortest path. How do you find out minimum path? So find out all the paths between node U and V, right? Assume nodes U and nodes V, find all possible paths between U and V, and out of all these paths, whichever is minimum, we consider that. So that is called the minimum path or the shortest distance. Okay. So the problem that we are supposed to study as of now is single source shortest path problem. So the problem is, given a weighted directed network or even undirected network, doesn't make much difference. So we will be solving one problem of undirected network and one problem on directed network, so that we will be able to understand both. The procedure is the same, no difference in it, right? So given a directed or an undirected weighted network called G, we are supposed to find out the minimum weight path or the shortest path from a specified source or a given source node S to all other vertices V or all other nodes V. Okay. So when I say minimum weight, you can also replace it with shortest path. So weight of the path, as we have defined earlier in the previous class, it is the sum of all the weights on each of the edges. On the edge, whatever weight we have written or whatever maximum capacity we have written. So if at all I add up those capacities on the given or the on the specified path, then that becomes the weight of the path. Hope the concept is clear. Shall we move ahead? Okay. So the basic idea behind Dijkstra's algorithm is, see, if at all I have a path U to V, right? There is an edge U to V, and there is also an edge possible from U to X and from X to V. So my idea is, if at all the distance U to V is less than distance from U to X and X to V, I will not consider it. If at all the direct path distance is greater, then I would not consider this direct path, but I will be traveling across the indirect path, so that that becomes my shortest distance. See, if at all you have not understood, let me give you a very simple analogy for this. See, from U to V, you have a direct road or a straight road. In this road, you are supposed to travel 4 kilometers to reach from source U to destination V. How many kilometers? 4 kilometers. So it is a straight road directly connecting U and V. But instead, you have an alternate path also available. From U, you can go to X. So the distance is 2 kilometers. And from X to V, you can reach, and the distance is 1 kilometer. So which path you will take? So when you are supposed to consider the shortest path, so this is 4 kilometers, and this, when you add up, it is 2 kilometers plus 1 kilometer, 3 kilometers. So in that case, I will not go in the direct path here, but I will go in the indirect path. So that is the basic idea behind Dijkstra's algorithm. Okay. So we will have a look at the algorithm concept now. What does Dijkstra's algorithm say? The algorithm says, label each node with the distance infinity. So first assume that there are no edges in the network, and assume that there are no paths available. All the nodes are disconnected. That being the upper limit, right? We call that as the upper bound. For all the vertices, we put the distance as infinity. Then for the starting node, whichever has been identified as your source node, right? For that, we will label the distance as 0. Then D of V is the distance label for V. Then we try to find out the distance of V. So distance of V from where? From the source, yes. From the source or from the start node. So from the start node to each and every node, I try to find out the direct distances and I call it as dV, distance of V. Put all the nodes into a priority queue using the distance as labels. See, don't worry much about what is a priority queue, how the implementation goes on, all that. You need not bother. So what I am trying to do is, I am trying to find out of all these distance labels, whichever is the shortest distance, that will appear first. That's all. Okay? That will be in my highest priority. So I will pick that shortest distance. Okay? So while Q is not empty, what are we supposed to do? U is equal to Q dot remove min. So the minimum most distance is removed from the Q. So that between V and U, I have now found a shortest path. For each node Z, which is one hop away from U. Now what am I trying to do is, in the first step, I found out a shortest distance between U and V. Now I am finding a shortest distance between U and Z, where V can be intermediate node. That is, from U to V I can go and from V to Z I can reach. So for such hops, I am trying to find out the distances and I will add that, or I will update that in my distance labels, right? For each node Z, one hop away from U, find D of U plus distance from U to Z. If it is less than D of Z, then D of Z is equal to U, D of U plus distance from U to Z. Fine. If at all you have not understood, nothing much to bother. When solving the problem, you will be able to understand it very clearly, right? And one more thing I just wanted to tell you, today I think we would have a bit of a lengthy session because we will be learning what is single source shortest path, we will be looking into the algorithm and we will be solving two problems on it. So therefore, the session might get extended a little bit. Okay. So in form of a pseudocode, if at all I write the Dijkstra's algorithm, Dijkstra graph or the network G is the input. For each vertex V in the vertex set, D of V is equal to infinity. So I am specifying or I am initializing with the upper bound. Then D of S is equal to 0. For a particular source S, I am setting the distance to be 0. Then all the vertices in vertex V will be added on to the Q. While Q not equal to null, till the Q becomes empty, what I will do is extract the minimum distance from Q, add that onto the source, and after adding it onto the source, for each new vertex U which is adjacent to V, find if D of V is greater than D of U plus distance from U to V. If it is greater, then D of V is equal to D of U plus W of U comma V. So very simple algorithm. So at present, if at all you have not understood, don't bother much. After solving the problem, come back to the algorithm and have a look. You will be able to understand it very easily. I know that you people are finding it tough in this particular portion, right? This portion you are finding it tough. I know you people might have little bit of confusions in this portion. So once you solve the problem, you can get back and have a look at the algorithm. This will appear very simple to you. Okay. So shall we have a look at the problem? So let us consider one problem. Here I have taken an undirected network. Okay. The node numbers are 0, 1, 2, 3, 4. So totally 5 nodes are there, and this is the given network. So whenever I am supposed to solve the given network and find out the shortest distances, I will represent this network in form of a cost adjacency matrix. So I will convert the given diagram into a matrix form. So from 0 to 0, there is no self loop, therefore distance is 0. From 0 to 1, distance is 3. Okay. So 0 to 1, distance is 3. From 0 to 2, there is no direct path between 0 and 2. Therefore, I consider the distance to be infinite. There is no direct path. That is what has been specified, upper bound. If at all there is no path, then the distance is the upper bound. It is infinity. Then 0 to 3. 0 to 3, there is a line with the distance 7. 0 to 4. 0 to 4, distance is 8. I have written that. Then coming to 1 as source. So 1 to 0, 3. 1 to 1, self loop, therefore 0. 1 to 2, distance is 1. 1 to 3, distance is 4. 1 to 4, there is no direct path, infinity. 2 to 0, no direct path, infinity. 2 to 1, 1. 2 to 2, self loop 0. 2 to 3, I have a connection, therefore 2. 2 to 4, no direct path, infinity. Then 3 to 0, 7. 3 to 2, 3 to 1, 4. 3 to 2, 2. 3 to 4, 3 to 3, self loop 0. 3 to 4, 3. Now coming from 4, 4 to 0, 8. 4 to 1, no direct path, infinity. 4 to 2, no direct path, infinity. 4 to 3, 3. 4 to 4, self loop 0. So you've understood the matrix. Now in this problem, they have not specified explicitly which you are supposed to consider as source. So I will consider node number 0 as a source, right? I am assuming node 0 as a source. So my problem is to find out the distance from 0 to 0, 0 to 1, 0 to 2, 0 to 3, 0 to 4. Right? The problem is to find the shortest distance between 0 to 0, 0 to 1, 0 to 2, 0 to 3, 0 to 4. Okay? So we are supposed to solve it. So starting with considering the source. Which is the source? 0. So my direct distances from the source will be 0 to 0 is 0, 0 to 3, 0 to 1 is 3, 0 to 2 is infinity, 0 to 3 is 7, 0 to 4 is 8. Okay? So I will consider this. I am solving the problem in form of a tabular method. So I will consider the first column as yes, representing source. So I have considered, this is 0. A typing mistake. This is 0. Source is 0. So source 0, remaining vertices are 1, 2, 3 and 4. Okay. Next I am supposed to find out the labels dv. So v is nothing but the vertices in vertex set v. So I am supposed to find d of 1, d of 2, d of 3 and d of 4. So what is d of 1? Distance from source to v. So distance from 0 to 1, distance from 0 to 2, distance from 0 to 3, distance from 0 to 4. So distance from 0 to 1 is 3, 0 to 2 is infinity, 0 to 3 is 7, 0 to 4 is 8. That is what I have written. 0 to 1 3, 0 to 2 infinity, 0 to 3 7, 0 to 4 8. So now I have put all the labels. Out of the labels, whichever is the minimum value, see in the algorithm I had written q dot remove min. So I am removing that minimum value. Out of all these values, which is minimum? 3. So the minimum value is 3. Which is the node leading to that value? D of 1 is 3. So node is 1. So 0 to 1 distance is 3 and it is a direct path. If you want, you can just verify 0 to 1. It is a direct path with distance 3. Okay. Now 0 and 1 are joined. So 1 also becomes the source. Right. 1 becomes my new source. Right. Earlier my source was 0. I had started from 0. Now I am using the new node that I have added as the intermediate node. Now I am supposed to find out the distance from 0 to 2 passing through 1, 0 to 3 passing through 1, 0 to 4 passing through 1. So passing through 1 is what we are supposed to consider. Therefore 1 is my new source, right? So I will make a note of all the distances from 1. So 1 to 0 is 3, 1 to 1 is 0, 1 to 2 1, 1 to 3 4, 1 to 4 infinity. So now coming to the problem, 0 and 1 are my sources. Remaining vertices, 1 is already added to the source. So from the vertex set it will be removed. So what are all remaining in vertex set? 2, 3 and 4. Okay. 1 and 0 and 1 are in the source. Remaining will be vertices. 2, 3 and 4 are my vertices. For 2, 3 and 4 I am supposed to find the label d of v. So d of 2 has to be found, d of 3 has to be found, d of 4 has to be found. So how do I find out? D of 2 is minimum of d of 2, which is the value from the previous step. D of 2 from the previous step is considered, and the second part says using 1 as intermediate. 0 to 1, distance from 0 to 1 plus distance from 1 to 2. Okay. So what was d of 2 in the previous step? Infinity. What is d of 0 to 1? Minimum value from the previous step. That is 3. Then d of 1 to 2. D of 1 to 2 is 1. Right? 1. So the value becomes minimum of infinity comma 3 plus 1. So 3 plus 1 is 4. When you compare infinity and 4, which is minimum? 4. So d of 2 is 4. Similarly, calculate d of 3. D of 3 is equal to min of d of 3 from the previous step, comma minimum value from the previous step, plus d of 1 to 3, distance from the new source, 1 to 3 distance. So d of 3 from the previous step is 7, minimum value from the previous step is 3 plus distance from the new source from the table. When you have a look, 1 to 3 is 4, so the value is 4. So value from the previous step was 7. Then in the second side you have 3 plus 4, this is also 7. So whether you consider first or second, both are 7, so you write a 7 here. Next, coming to d of 4, minimum of d of 4 from the previous step plus d of 0 comma 1, which is the minimum value of the previous step, plus d of 1 comma 4, distance from the new source 1 to 4. So d of 4 from the previous step is 8, minimum value from the previous step is 3, d of 1 to 4 is infinity. So you have 8 comma 3 plus infinity. 3 plus infinity is infinity only. So 8 comma infinity, which is minimum? 8 is minimum. So now I have got 3 labels, 4, 7 and 8. Out of this, q dot remove min, minimum value has to be removed. Which is the minimum out of 4, 7 and 8? 4. So which is the node leading to it? 2. Okay. So 0 to 2, the distance is 4. 0 to 2, distance is 4 that we have got. So look into the problem and see 0 to 2 with 4. How can I get? So when I move from 0 to 1 and 1 to 2, 3 plus 1, it becomes 4. So I write it is an indirect path along 0 to 1, 1 to 2. Okay. Now 2 gets added onto the source. My new source becomes 0, 1 and 2. Because my new source is 2, I need to make a note of all the distances from 2. So 2 to 0 infinity, 2 to 1 1, 2 to 2 0, 2 to 3 2, 2 to 4 infinity. Right? We will use this in the next step. So 0, 1, 2 is the source. Remaining vertices are 3 and 4. I am supposed to find out d of 3 and d of 4. D of 3 is minimum of d of 3 from the previous step, which is d of 3 from the previous step is 7. Then d of 0 comma 2, that is minimum value from the previous step, 4. Then d of 2, 3, distance from the new source, newest source is 2. So 2 to 3 distance has to be calculated. So it is min of d of 3 from the previous step is 7, minimum from the previous step is 4, distance from the new source is 2 from the matrix. So minimum of 7 comma 4 comma 4 plus 2. So 4 plus 2 is 6. So compare 6 and 7, which is minimum? 6. Okay. Similarly, compute d of 4. D of 4 is equal to minimum of d of 4 from the previous step 8. D of 0 comma 2, minimum from the previous step 4. D of 2 comma 4, distance from the new source, it is infinity. So d of 4 from the previous step is 8. D of 0 comma 2, minimum value from the previous step 4. D of 2 comma 4 is infinity from the matrix. So you get minimum of 8 comma 4 plus infinity. 4 plus infinity is infinity. So when you compare infinity and 8, which is minimum? 8 is minimum. So I have got the two labels, 6 and 8, which is minimum? 6. So minimum value is 6. Node leading to minimum value is 3. So now 3 gets added to the source. Okay. And the distance between 0 to 3 from the source to 3, 0 to 3 is 6. So now look into the problem. 0 to 3, direct path is actually 7, but I am getting an answer 6. So it should be an indirect path. 0 to 1, 1 to 2, 2 to 3. So it will be 3 plus 1 plus 2, 6. So shortest distance is not direct but an indirect path. 0 to 1, 1 to 2, 2 to 3. See, that is what I have written here. 0 to 1, 1 to 2, 2 to 3. Okay. Now 3 also became my source. So I will have to highlight the new source values. So new source values are 3 to 0 is 7, 3 to 4, 3 to 1 is 4, 3 to 2, 2, 3 to 3, 0, 3 to 4, 3. So we will use those values here. So now 0, 1, 2, 3 are my source. The only destination or the only vertex available is 4. So find out d of 4. D of 4 is equal to minimum of d of 4 from the previous step, comma d of 0, comma 3, minimum from the previous step, and d of 3, comma 4, distance from the new source. New source is 3, so distance from the new source, d of 3, comma 4. Okay, d of 4 from the previous step is 8. D of 0, comma 3, minimum from the previous step, 6. Oh, sorry, I have done a typing mistake here. This is 6, not 4. Okay, and d of 3, comma 4. D of 3, comma 4 is 3. So this will be 6 plus 3, 9. So d of 4 is minimum of 8 and 6 plus 3, 9. So when you compare 8 and 9, you get 8. So minimum value is 8. Node leading to it is 4. So 0 to 4, it is 8. See, whatever I have typed here is a mistake. Let me correct it. Let me write it so that you people don't do the same mistake again. So this is not 4, this is 6. Okay, and this is 8. So minimum value is 8. So because I get minimum value as 8, so the path will be direct. 0 to 4, 0 to 4 direct path 8, right? So this is not required. Okay, so now 4 also gets added onto the source. 0, 1, 2, 3, 4, everything is in the source. No vertex set or the QV becomes empty. So I have to stop the problem here. Then write the final solution. D of 0 to 0, 0. D of 0 to 1, 3. It is a direct path. D of 0 to 2, 4. That is an indirect path from 0 to 1, 1 to 2. Then d of 0 to 3 is 6. So 0 to 1, 1 to 2, 2 to 3. 3 plus 1 plus 2, 6. Then d of 4 is 8, which is a direct path. So I need not write the path here. Whenever there is a direct path, I need not write the path. So d of 0 to 4 is 8. Okay. Any doubt with this problem? Hope you people have understood the concept. Shall we move on to the next problem? The next problem is bit bigger. I will go bit fast because now you people have understood the concept, basic idea behind it. So I will go bit fast in the second problem. So the problem 2 that I consider, the node numbers are A, B, C, D, E, F and G, and this is the network, and I have constructed the cost adjacency matrix, and the problem that I have considered is a directed network. So A to B will be 4, but B to A, there is no direction specified, therefore B to A will be infinity. Okay, A to B is 4, but B to A is infinity. Hope you people have understood. Based on the directions given, I have constructed the cost adjacency matrix. Whenever you have a directed graph, you are supposed to pick the source node. Which has to be picked as the source node? A specific node which has only outgoing edges and no incoming edges. That node is called source. In this problem, you don't have any such node, right? A has one incoming, B has one incoming, C has one incoming, D has two incoming, E has two incoming, F has three incoming, G has two incoming. So there is no node which has no incoming edges. So therefore, you can pick any of them as the source. So I will pick A as the source and start solving the problem. Okay. So I'll consider A and all the distances from A to A 0, A to B 4, A to C infinity, A to D infinity, A to E infinity, A to F 5, A to G infinity. Using this, I will find out D of A is the source, B, C, D, E, F, G. These are the remaining vertices. So D of B is 4, D of C infinity, D of D infinity, D of E infinity, D of F 5, D of G infinity. So out of all these values, which is minimum? 4. So node leading to it is B. So A to B minimum distance path is 4. A to B with distance 4. So it is a direct path. Okay. So I just write it as direct. When going to the next step, B becomes the new source. So make a note of all the distances from B. Infinity, 0, 2, infinity, 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 1 are the new distances. So now A and B becomes the source. Remaining vertices are C, D, E, F, G. So D of C is minimum of D of C from the previous step, infinity, and minimum from the previous step, 4, and distance from the new source, B to C. B to C is 2. So minimum of infinity comma 4 plus 2, minimum is 6. Then D of D, minimum of value from the previous step, infinity, minimum from the previous step, 4, and distance from the new source, B to D. So BD is infinity. So the value will be minimum of infinity comma 4 plus infinity. 4 plus infinity is also infinity. When you compare infinity with infinity, infinity is only minimum. Okay. Then coming to D of E, min of value from the previous step, infinity, minimum from the previous step, 4, distance from the new source, BE. BE is also infinity. So value from the previous step is infinity plus minimum from the previous step is 4 and distance from the new source is infinity. So it will be infinity comma 4 plus infinity. So minimum obviously will be infinity only. Coming to D of F. So D of F from the previous step is 5. Minimum from the previous step is 4 and D of BF. BF is infinity. So minimum from the previous step is 5 comma 4 plus infinity. So minimum is obviously 5. Then DG. d of g. So minimum of dg from the previous step infinity, d of the minimum from the previous value from the previous step 4, and d of bg from the matrix, it is 1. bg is 1. Yeah, bg is 1. So we get minimum of infinity comma 4 plus 1. 4 plus 1 is 5. When infinity and 5 are compared, 5 is only minimum. So now out of all these values that I have got, which is minimum? 5 is minimum. So I have minimum in two places. Then what to do? You can pick any one of them. So I will pick the first occurrence. So minimum value is 5. Node leading to it is F. First occurrence I have taken. So F. So from A to F, the value is 5. A to F value is 5. It is a direct path. That is why I have written A to F 5 direct. Now F becomes added to the source. So I need to make a note of all the distances from F. Everything is infinity because there is no outgoing edges from F. Okay. So now A, B were already in the source. Now F gets added to the source. Remaining is C, D, E, G. So D of C is D of C from the previous step 6. Then minimum from the previous step 5. And distance from the new source FC is infinity. So minimum of 6 comma 5 plus infinity. Obviously minimum will be 6. Then D of D, value from the previous step infinity, distance from the minimum from the previous step 5, distance from the new source FD. FD is infinity. So it is infinity. I will use a highlighter, pointer, so that you will be able to see better. So infinity plus 5, infinity comma 5 plus infinity. So minimum is obviously infinity. Then check distance of E, value from the previous step infinity. Then minimum from the previous step 5, distance from the new source FE. FE is also infinity. So I get infinity comma 5 plus infinity, which will remain infinity. Then coming to dg, dg value, once again a typing mistake here, I believe. Yes, there is a typing mistake here. Why did I do this mistake? Okay. dg is minimum from and value from the previous step 5 and minimum from the previous step 5, distance from the new source f to g is infinity. So 1 minute, I expect you people to just remain online. I will edit it here only. Just a minute, I'll type it here. Sorry that I have done a mistake while solving. I've done a very small mistake. This is 5. This node becomes G. Okay. So the shortest distance is 5 and the node leading to it is G. So A to G will be 5. Okay. Look at the diagram. A to G 5. So it is an indirect path from A to B and B to G. So it is indirect path A to B, B to G. Okay. So next, G is the distances that I am supposed to look into. G is the distances that I am supposed to look into. It will be 2 infinity, infinity, 2, 4, 8, 0. So A, B, F, A, B, F, G becomes the new source. I am left out with C, D, and E. C, D, E are left. So D of C will be minimum of A to C, that is value from the previous step, D of A to G, and D of G to D, that is minimum from the previous step is 6, minimum from the previous step here is 5, so 5 plus distance from the new source G to C. G to C was infinity. G to C is infinity. So out of these two values, which is minimum? 6 is minimum. Okay. Next, find D of D. So it is D of A to D, comma D of A to G to D of G to, this is C, G to D. G to D value was 2. So it is value from the previous step. D of D from the previous step is infinity, and minimum from the previous step is 5. Distance D to G, G to D is infinity. So minimum will also be infinity. Okay. Next, D of E has to be calculated. D of E is minimum of A to E, D of A to G, and D of G to E. So this is value from the previous step. D of E from the previous step is infinity. Then distance from the new source, minimum from the previous step is 5, and distance from the new source G to E, G to E is 4. So this will be 4. 5 plus 4, 9. So I've got 6 and 9. So minimum is 6, node leading to it is C. So I get C, A to C, 6. A to C, 6. Is it direct? A to C, 6 is A to B, B to C. Indirect, A to B, B to C. Okay. Then C gets added to the source. C gets added to the source. That becomes my new values that I am supposed to take. The values are infinity, infinity, 0, 10, infinity, infinity, 3. Okay. So I'll just copy it from here. So now I've got G as the old source, C as the new source. So left out nodes are D and E. So D of D is minimum of D of A to D, D of A to C, and D of C to D. That is minimum from the, oh sorry, value from the previous step. D of D from the previous step was infinity. D of D from the previous step is infinity. Minimum from the previous step is 6. Distance from the new source C to D, C to D is 10. So I get a 6 plus 10. So which is minimum out of these two? 16 is minimum. Then D of E will be minimum of D of A to E, D of A to C, and D of C to E. That is value from the previous step. D of E from the previous step was 9, and minimum from the previous step is 6, and distance from the new source C to E, C to E is infinity. C to E is infinity. So out of these two, which is minimum? 9 is minimum. So minimum value is 9. Node leading to it is E. Okay. So A to E with value 9. So check whether it is direct or indirect. A to E with 9. So it would be 4 plus 1 plus 4. A to B, B to G, G to E. A to B, B to G, G to E. Okay? Is the concept fine? I'll copy this. For the next step, E becomes the new source. E becomes the new source. So these values have to be noted. The values are infinity, 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 0, 1, infinity. Okay? So here I'm just pasting the previous step values. So that this particular step I'll be able to solve it correctly. So the new source, the order in which I've got is, here I've got G, then I've got C, then I've got E. I'm left out with D. So D of D will be minimum of D of A to D and D of A to E and D of E to D, which is value from the previous step. D of D from the previous step is 16 and minimum from the previous step 9, and the distance from the new source E to D. What is E to D? Infinity. E to D is infinity. So the minimum value is 16. Okay. So minimum value is 16. Node leading to it is D. Node leading to it is D. So A to D value is 16, which is obviously an indirect path. A to D with 16 will be 4 plus 1, 5, 5 plus 2, 7. Oh, sorry, to E, right? Oh, okay, sorry. No, to D only. So 4 plus 1, 5, 5 plus 2, 6. So 6 has to be the answer, A to D. Somewhere we have done a mistake while copying the values. Hope you have understood the concept. I'll resolve this problem and post the PPT, for both the problems on the classroom platform. If at all you have understood the concept, just let me know. If at all you have any problems, you can just post it on the classroom platform. Fine. In the next session, once again, I will be posting these problems on the classroom platform. I'll just post the PPT on the classroom platform. If at all you want me to solve the problem again, you just let me know on the comment section. If not, I'll continue with the next problem, which is all pairs shortest path. Thank you. Thank you for your patient listening. Have a nice time. Enjoy.